BNAC pushes the boundaries of neuroimaging and leads directly to saving lives, in improving healthcare, and in improving the lives of people with neurological disorders.
BNAC strives to extend the boundaries of the current knowledge about neurological disorders like multiple sclerosis, Alzheimer's and Parkinson's disease and strokes, among others, through innovative imaging research techniques and the application of bioinformatic resources, including artificial intelligence.
We have an important opportunity to finally investigate what are some of the structural changes in the brains of these individuals.
The BNAC represents a very unique asset for MS researchers in Buffalo because it has enabled us to conduct studies across a range of disciplines that we would not be able to conduct independently or alone.
BNAC's research focuses on applying magnetic resonance imaging in rigorous and innovative ways to better understand the onset, progression, and underlying mechanisms of MS and other neurological diseases. Using techniques including quantitative brain volumetry, susceptibility-based iron imaging, diffusion connectivity, resting state functional imaging, myelin-sensitive imaging, and others, BNAC has been able to show how current treatments affect brain atrophy, how functional flexibility can help compensate for structural damage, and how remyelination can be promoted. We want our research to make a difference on real-world clinical outcomes. So, a major recent effort has been to develop translational algorithms for tracking whole brain and gray matter on regular clinical routine images, so that we can see how individuals are responding to therapy.
One of the research areas that we have been actively working on is brain connectomics. So we're looking at structural connectivity as well as functional connectivity, how disparate aspects of the brain talk to each other essentially.
Another key technology here at BNAC is brain iron MRI. We use a unique technique called quantitative susceptibility mapping, or QSM for short. This technique allows us to study how neurological diseases affect tissue iron in the brain and how these alterations modulate disease activity. We also continuously improve imaging techniques like QSM to make them even more accurate and detect tissue pathology earlier and more precisely.
For more information on how BNAC Research can help patients, clinicians, or drug manufacturers, visit us on the web at www.bnac.net.